Hi, let's get started with the mean. So mean usually we refer to arithmetic average. So it's the sum of all the observation divided by number of observation. So it's a fraction. So the notation will be, we denote mean usually x bar, say little underline overline here is x bar, and with a fraction, okay, and the denominator will be number observation, which is n we have here, and the data or the observations we have is x1, x2, x3, x4, x5 up to xn. So the summation notation means x1 plus x2 plus x3 up to xn. So the calculation is very simple, just basically sum of them divided by how many of them. So example will be the following. So suppose we have a first data set, we have 5 numbers, 1, 2, 3, 4, 5. So the mean x bar will be a fraction. The denominator is 5 because we have 5 observations. The numerator will be adding all up is 1, 2, 3, 4, 5. So adding all up is 15. 15 divided by 5 is 3. And the second data set is 1, 2, 3, 4, 50. So which is essentially the same, but the last one instead of 5 become 50. So add them all up, the numerator will be 60. 60 divided by 5 is 12. Okay, so it's very simple, just add them all up and divide by how many of them. And this is very simple, right? And you can see we just add them all up means that they have a similar importance, right? But sometimes you may not think that's a correct way. So we can generalize this concept to what we call the weighted average, right? The mean we have is just put equal weights, okay? But sometimes you don't want to do it. To generalize this concept, we would have to have a generalized mean, which is weighted average, which is very similar. You can see we have a new thing we call WI, which is the weighting. So each observation, x1 we have weighting W1, and x2 with W2 and xn with Wn. So we have each observation one weighting, and weighting is some positive numbers. And so you can see which very similar, but the denominator become not just n, will be sum of all the weights, and the numerator will be a each observation multiplied by its own weight, and we add all the weighted observation divided by total the weight. So if you put all the weights equal to 1 or some any arbitrary number which is the same, then you will see you can simplify the formula. Expression is 1. So the denominator become 1. Okay, the numerator will become just xi, so which is same as the arithmetic average we have before. So what are the uses of this weighted average? Why we want to put different weights or different observations? Because for example, look at the stock prices or housing prices. Okay, if you want to look at the trend, you would think the more recent observation are more important than the long distant past prices, right? The more recent price will be reflecting more recent development of the underlying economic scenario situation. So that's why you want to put more recent price at higher weight. And if you talk about the return of investment portfolio, okay, if your portfolio consists of several stocks and you put the same money divided equally into different stocks, then your return of your portfolio will be just a simple arithmetic average of return of each stock. Okay, but usually you don't do it. You may divide unequally. You invest more in one stock, less on the other. Then to calculate the return of portfolio, actually is calculating the weighted average. Okay, so the weighting will be the percentage of the investment of particular stock in your investment portfolio. Okay, another one common one is the stock index. Okay, hence the index, for example, the stock index in Hong Kong stock market is the average of 50 largest stock. Okay, but this is not just simple average. Instead, it's a weighted average. So the weight is by the market capitalization, which means that if the stock is larger company, has larger market capitalization, should carry more weight. So market capitalization is the price of the stock multiplied by outstanding shares. Okay, and what we have taught is just adding all observation. That's why it's arithmetic, because it's adding up. It's just simple to calculate. But with advance of calculator or computer, then it becomes easier to calculate other means, which is not easy possible in old days, which is called geometric mean. Okay, is instead of adding up, it's multiplying. Okay, it's multiply all the observation and take the nth root. Okay, basically just multiply them and take the root. Okay, and usually this is used to calculate the average of the return. Okay, if you have first year you have such a return, second such a return, and first such a return, the best way to do is to calculate the geometric mean of the return instead of the arithmetic, because return usually compound, so geometric would fit the idea. And the other one is harmonic mean, which is less common, but sometimes you would use it. The formula is also a fraction. Okay, instead of, remember the average one is arithmetic mean is the denominator is n, but now we put n as numerator. Okay, but what denominator now is the sum of all observation, but it's an inverse observation, is 1 over xi. Okay, and we often use it as calculate the average of ratios. So this is less commonly used, but harmonic mean do have its own purpose.